This video, we talk about how to start a new seismic imaging project. First, we need to well understand what we will do for the project, what's listed on the contract. Second, we need to check dataset and document received from the client. And we need to set up a geometry with a loading sheet from a client. We need to decide import data area, output data area, and the model building size. And we need to load dataset into the system, and QC dataset and the model delivered from the client, if any. We need to prepare input data and the initial model for the formal processing. We need to prepare the job set, job deck, and set up a script and prepare what software we need for the processing. Okay, for this video, we first check the data. We use the open data from SEG website. It's called Qiyu.Han 3D dataset. Let's take a look at what we have. We got a document and import date, and we lost the model, and we'll log data and document. Let's check what's document. The first one is a 2D data load sheet. Okay, the 2D data. This 2D line is like a random line, or we see oblique line. So from the dataset, we don't have a 2D line. We got a 3 dataset, all 3D, no 2D. The 3 dataset, so one is time migration post-stack image. One is CMP input data, and one raw short gathers. So we don't have a 2D line. We ignore this. This document is a 2D navigation line. No, we don't have a 2D. 2D seismic base map. No, we don't have. We don't have the 2D data, so we ignore this. This is polygon. This polygon shows data area. The next document is reservoir data. reservoir data, like reservoir data among Rocky Mountain Oilfield Testing Center, Qiyu.Han. The list the production, reservoir pressure, depths, reservoir depths. There's net thickness. There's permeability, porosity. This data is good for building power media model. Okay, this data is Seismic readme. Okay, this readme file shows the Qiyu.Han seismic data set. Rocky Mountain Oilfield Testing Center, Qiyu.Han, Natrona County, Wyoming. Table of contents 2D seismic data. We don't get that data, no that data. 3D seismic data. Interpret the 3D seismic horizon. Let's check if we have a horizon. We don't have this horizon. And time depth table, synthetic program. Yeah, that's we have a reservoir information sheet. That document is an old document. It's from 2007. June 13th. Yeah, that's synthetic data, well-timed data. Okay, that's loading sheet of 3D data. That's a necessary document to load the data into the system. Next document is a processing document. It lists the processing history, processing sequence. Yeah, that's the processing. Post-stack migration, Powder River Basin, Natrona County, Wyoming. The data, where the data from, and the information. Yeah, that's important. The processing history, like geometry application, record and trace edit, reflection, static, amplitude recovery, surface consistent amplitude scaling. medium phase conversion, spectral balance, statics, CDP salt, velocity analysis, surface consistent residual statics, second iteration velocity analysis, second iteration surface consistent residual statics, NMO, trace equalization, first break mu, static to final flat datum, DMO, inward AMO, velocity analysis, NMO, mu analysis, CMP stack, FX domain predictive filter, band pass, trace scaling, output segue. Okay. Oh, that's a time depth table. Okay. Time depth conversion. Velocity model. Okay, that's the DMO velocity, post the DMO velocity. Primary key name CDP, second key name time, C key name velocity. Okay, CDP time velocity. Okay. The CDP is a 3D CDP, okay. How to get the CDP, how to calculate the CDP, we can take a look from the 3D loading sheet. Okay. That's XY CDP1. So this corner is CDP number 188. This CDP, the third one. 64,673. Yeah, that's the last CDP. Okay, so that's how to get the CDP. This velocity is we can use this for the initial velocity. Based on this velocity, run the migration. Another data set is well log data. We have log files in LAS format. Yeah. Okay. That's a bitmap. Yeah, that's a bitmap. That's a polygon. Data area. Inside the polygon, the data area. Formation. This is an example of a well log. This is This is a well log header. Yeah, that's information we need. Well log name. Well log name. That's well log x, y, and well log depth, datum. Yeah, that's ground elevation. That's we need. The location, we don't need this location once we use the x, y. This one is geology formation. The black dot is currently productive layer, and this productive in the past, like those two productive in the past, and the white area target is potentially productive. Okay. This is a well log readme file. Well header directional survey, the deviation, bitmap, large files. Okay. So next we see how to set up geometry. Geometry information is about inline, cross line, x and y, and the beam size 110 by 110 feet, and the inline range from 1 to 345, totally 345 line number, inline number. Cross line number from 1 to 188, totally 188 cross line number. That's information from a loading sheet. From this one, we already look at like that's the information necessary. We can get this information from other like other document like apt header. No, we check apt header like 3 data set. Let's check the Seismic header. This file. Seismic header, apt header. We run the job. We can see the SMP headers apt header. See the client is Rocky Mountain Oilfield Testing Center. Project Navas Petroleum Reserve number 3, 3D data. The CTP gathers with statics low NMO at floating data. It's not an NMO gathers, right? Inline X line, inline 1, X line 1, the XY. XY, that's first corner, second corner, third corner. It's only these 3, so because it's a rectangular area, so we know 3 corners, so we can calculate the last one, the fourth one, right? in line number from 1 to that's the same with a loading sheet, right? That's same one. General segue information output data length 4 seconds, 96 milliseconds. Sample interval 2 milliseconds. Data format 4-byte IBM floating point standard segue. Byte 181, 184 CDP-X, 185, 188 CDP-Y coordinate. Byte 189, 192 inline number. This cross line number, short point number, receiver location number, static shift datum key, geometry processing steps like geometry edit, airbrush attenuation. That's the processing history. Amplitude recovery, trace equalization, medium phase conversion, and surface consistent amplitude balance, short receiver balance, surface consistent decon short receiver spiking, reflection static, the datum to 95. Time variant spectra whiting, 2 iteration velocity analysis, and post NMO mu processed by Excel geophysical service. Okay, that's the CMP header. We can check the shortcut header. Run this job, get header information. That's the same. This is the field data with geometry. That's geometry. That's the same. That's a trace header location. That's raw shortcut. Let's check the stack, post stack volume. That's job. That's filtered post stack migration. Post stack migration, stack first, then run migration. That's geometry information. This rect length 3 seconds, sample rate 2 milliseconds. That's a key location. Okay. Next, we check the data we got. We first check the stack, post stack time migration, right? We run this job. Okay. This X line. That's E line. That's E line. We check this. We That's applied post processing. Look, it's like a gain something. Okay. We can check the slides. Looks good. Okay, we then check CMP. Because the CMP and the short data set is big, we QC only a few segment. In the QC, we apply time gain. Okay, that's true. Okay, that is C. That's CMP gathers. Change the gain, for example, to 0. Yeah, that's a new gain. Change it to a bigger number, like 3. Oh, that's too much. Gain too much, right? Okay. Next we check the short gather. We apply gain to short gather. We can see there's noisy trees, and there's a surface view. Noisy trees. There's noisy trees. So in the pre-processing, we need the noise or kill those trees. We can use the despike, right? Despike or similar procedure to denoise.